Testing, testing, 1, 2, 3. Can I be seen? Can I be heard? Is everything cool? Am I a little low? Law. I think it'll be fine. Yeah, I think that's good. Good morning, Fancy Meat Computers. How is everybody doing today? I hope that nobody got caught in that huge thunderstorm that we had in Hamilton just yesterday. It was quite something, I have to say. I saw the neighbor in the backyard taking pictures of the clouds, and then I saw my wife doing the same thing. So, good. Glad to hear you're all doing well. It was quite the storm. Boom, boom. Oh man, you are going to see the entire bow tie collection over the course of this course. I have between 20 and 30 of them. It's kind of one of those things, like, once people know that you wear bow ties, that becomes the easy gift for you for a few years, so you sort of accumulate a collection of them without really having to exert much effort. So, yes. I'm doing well. I'm doing pretty well. Yeah, everything's cool on my end. So, let's get right into it, shall we? Oh, crap. Yes, no, I forgot. There was a thing. There was a thing that I forgot to talk about last time with respect to the with respect to the syllabus, because I want to try this cool new thing. So in previous iterations of this course, we just had the Piazza Forum, and it's like everything was fine. But in this iteration of the course, I want to try a pilot program that was suggested by my dear friend and TA, David. We're going to do like kind of a competition. We've got the same headset. Wow. This one? Yeah, I like this one. So we're going to have a bit of a competition with the with Piazza this semester. So one of the interesting and cool things about Piazza is that you can ask questions, but you, the student, can also answer questions asked by other students. So this is what we're going to do. In addition, sorry, pardon me, back me up a little bit. Another thing that Piazza does is it allows us, the instructors, to endorse either the questions or the answers that are provided by you, the students. So, at the end of the semester, we're going to tally up all of the instructor-endorsed questions and answers, and we're going to award a few extra points to the top 3 in both categories. So the top 3 questioners, that is, the top 3 people who asked the best questions, according to our evaluation of that, they will get an extra 2% for their final grade. Again, a question must be instructor endorsed to count towards your total, so there's no reward for spamming. And also, the top 3 answerers will receive an extra 4% on their final grade. Again, your answer needs to be endorsed by an instructor to count. And these extra bonus grades cannot, obviously they cannot increase your maximum grade beyond 100%, because that's nonsense. But yeah, might be enough to get you from an A to an A+. So there you go. Yeah, so that's one policy that I wanted to test drive this semester. So now that you're aware of it, I expect all of you to be the best answerers and questioners. And of course, that sort of begs the question, well, what does a good answer, quote unquote, look like with respect to like how do I get these sweet, sweet bonus marks? And the answer to that is, your answer should be useful. If your answer is well phrased, answers the question well, then that's a good answer. And if your question is if your question is an intelligent question, or something that's important, then basically things will be weighted towards, you'll get these endorsements more if your questions are useful for lots of people and not just yourself. But yeah, so that's it. So let's get to it. This is going to be my fidget object today. So that's actually, it is a lot like Stack Overflow. The one exception with Stack Overflow, though, is that in Stack Overflow, all of the baseline users can vote answers up and down, kind of like on Reddit, actually. Yeah, the Stack Overflow is basically like Reddit, but exclusively devoted to programming questions. Which, incidentally, if you didn't know what Stack Overflow is, Stack Overflow is kind of your, we're trying to model Piazza after Stack Overflow to some degree. Stack Overflow. There you go. So this is the Stack Overflow website. If you have any question, probably it's if you have pretty much any question related to programming, it's probably already been asked and answered on Stack Overflow. It's just a matter of piecing together the answers from various sources, or understanding what the answer means. So, can you post questions and answers anonymously and still get credit for the bonus marks? I believe so. Yes, I believe that's true. So, I should say that anonymously means anonymously to your classmates and not anonymously to us. But yeah. So, to some extent. In actuality, Piazza keeps track of these statistics for me, so I don't actually have to do the manual tally. But yeah. For all of these people who are talking in the chat about how Stack Overflow is the holy grail of programming knowledge, that is true. The faster you turn Stack Overflow into your friend, the better a programmer you will be. So, yes, good, excellent. So that's just something that I wanted to talk about before we got into the lecture today. Cool! Let's do it! Lecture 1, Topic 1 of Computer Science 101, by which I mean 1MD3. But in other places it would be 101. Anyway, on programming. I can only speak to 1MD3 not having a tutorial this week. 1MD3 does not have a tutorial this week. So, let me think. Programming brain. Programming is about math. So, what is a program? Basically, a program is a series of mathematical statements that are understandable and executable by a computer system. Fundamentally, the language that the computer... can you get copies of the slides? Yes! They're all up on Avenue. Let me just enter my password in such a manner as people can't see it. Ho-ho. I can do that now with two screens. Oh, no. Oh, don't do that. Don't do that, no. No. There we go. Why aren't you locked? There we go. Alright. Streamer fail. Content. Topic 1. There you go. Ta-da! So when you're programming, basically you will be composing a series of mathematical statements that tell the computer how to calculate something. Programming is not like a spoken language. In a spoken language, you're dealing with concepts, right? When I speak an English sentence, I am trying to convey some kind of semantic thing pertaining to, the subject of the sentence, the verb that's in the sentence pertains to that, etc., etc. Programming is not like writing a sentence. It's a lot more like writing an equation. You should always think in terms of equations rather than in sentences. The reason I'm stressing this point is because I've watched far too many people who have no programming experience writing programs like they were writing sentences in a natural language. Incidentally, Natural languages are what us computer scientists call everything that's not a computer language. If you speak it, it's a natural language because it arose from nature. But yeah, so when you're writing a program, you are writing a series of equations that are going to be evaluated by the computer in a particular sequence. But because these programs are mathematical in nature, the things that they do are also mathematical in nature. So we use programs to solve math problems, basically. So, here are a few math problems. What is the square root of 25? I'm sure most of you already know this. What is the square root of some number y? That's a little bit more difficult. And you can't just say root y. The square root of y is a number x such that x times x is equal to y. I mean, you don't need necessarily 200 lines of bash just to... Well, maybe you do. It depends. If you're on Arch Linux, you might. But if you're on Mint or anything that a normal person would use... a good friend of mine once said that if you have any Linux distribution other than Ubuntu at the time, but I'm going to argue Mint currently, then you're just being a hipster. Which, there's nothing wrong with that, but you should understand that you're a hipster. So, here is a math problem. This is a math problem with what we call an algorithmic formulation. So, question. What is the x-intercept of a function f? An x-intercept of the function f is an x such that f at x is equal to 0. That is to say, it's the point at which this line crosses the x-axis. Suppose that f is a monotonically increasing function on the interval a, b. Monotonically increasing just means that for every point that's to the right, if you have a point... Let me rephrase. Pick any point on this line. Pick any point on the interval AB. Anything to the right of it is more than it, is higher. Anything to the left is lower. So there you go. Yeah. So, are you going to learn Linux? No, that's not the purpose of this course. If you want to learn Linux, take Computer Science 1XC3. That is a course that I taught over the summer, and I'll probably be teaching it again in the winter term. It doesn't run this term, it runs in the winter term. If you want to learn Linux, take that course. But we're not really going to learn Linux in this course. So we're going to go through an algorithm for determining the x-intercept with some precision epsilon. All right? If you're not getting this mathematically, I don't worry about it too much. This is the only time in the course that we're going to discuss problems that look like this. So, maybe once or twice as well. We'll revisit this when we talk about floating point numbers, but that's all right. Anyway, so epsilon is an error. In the recent polling that they've been doing because we have an election coming up, they'll say, the liberals are at 32%, plus or minus 3%. The error, or the epsilon, is the plus or minus 2%. So we want to be able to determine the x-intercept within that margin of error. So, this is what we do. So long as the interval size, that is, b minus a, the size of the interval, is greater than epsilon, we do steps 2 to 4. Step 2. We calculate the midpoint, m, So m is going to be halfway between a and b. We calculate what f at m is, right? If f at m is greater than 0, then we move this guy down. If f at m is less than 0, we move a up. The idea is that we're closing the interval around that x-intersect by a factor of 2 each time we iterate this algorithm. So, we'll take b, we move it over to where m is now. You can see that the x-intersect is right there. So if we take the midpoint again, say it's right here, right? We'd move b over again. Then we'd move a in, and that would just get smaller and smaller and smaller and smaller and smaller until eventually the size of that interval is less than the size of epsilon, which means that we have determined the location of the x-intersect within that error. So, yeah. So that's how an algorithm works. But notice that this, there are other ways to calculate this. Yeah, it's a binary search type algorithm. We are actually going to talk about binary search proper during this course. So, there are algebraic ways of formulating this same question, right? There are algebraic ways to do this, but this has been arranged as a sequence of small steps with some degree of, control over which steps are executed where. So this you can easily translate into a program, whereas an algebraic formulation, it might not be as easy to write it in a programming language like Python. You might need a different language, or you might need to reformulate your terms. So yeah, this is a similar algorithm to binary search. What is the benefit of using Linux? It's fast, and Microsoft doesn't snoop through your files or prevent you from ripping CDs. When you get to my level in computer science, it's like all of the programs that you need to use are Linux-based anyway, so it just makes sense to use Linux. Would this program work if the x-intersect wasn't in the interval AB? No, it would not. If the x-intersect is not in the interval, then it's not going to be able to find it. Yes. Could I explain that again? You can run the video back. Narrow down to the main... Yes. Again, because this is a YouTube lecture and not a MS Teams meeting, if you don't understand something that I'm saying while this lecture is going on, you can actually do a live rewind, like a minute or two, and then you can watch it back again. So yeah. So I gotta keep moving. I can't repeat myself too much. But yeah. So that's kind of what an algorithm might look like for a particular problem. So let's see. Do I see that ever again in this? Yeah, okay. Let's yeah, let's do it. Let's do this problem. Examples. So, I'm going to now program this guy using my own Linuxy type stuff. So, get it topic1.py. Topic1.py is a Python source code file. In order to write this particular example, I need to define a function. We'll call it, I'm just gonna, let's see, pop that there. There we go. define a function. Call it intersect. Takes a function f, an a b, and an epsilon. So, as long as b minus a is greater than epsilon, do other steps. That means a while loop. So, while b minus a is greater than epsilon, we calculate m. M is equal to a plus b, divide by 2. If f at m is less than or equal to 0, then a becomes m, else b becomes m, and then we continue, and at the end we return m, or return a plus b. That's not, this isn't on the page, but that's like a usual interpretation. So this is get it. It's GNU edit. It's basically the Linux version of Notepad. Yes, cool. So then now let's say we define a function f1 takes a value x. I just need a function that's monotonically increasing. Let's say return x squared minus 4. That should be fine. So now print the intersect of f1 on the interval from 0 to 10, because it's like this function is going to be parabolic, right, with a y-intersect that's less than 0. So it's going to intersect 2 times, but the interval from 0 to positive infinity will be monotonically increasing. So it matches our criteria, and let's have an epsilon of 0.01. Right? Now, I need a new terminal. There we go. All right. Now, I execute this by typing Python 3 topic1.py. And there you go. Those of you who are astute in the ways of computers and math will know that the correct x-intersect for this function is, in fact, 0. If you set this equal to 0, the square root of 4 is 2, so 2 is the correct intersect, right? So there you go. It has worked. And you notice we can set the interval a little tighter by modifying the epsilon. It'll find it with more precision, but it'll also take more iterations to get there. So let's just take a look at what's going on underneath the hood. So let's print a is equal to the value of a, print, oh, I should put this inside the loop, shouldn't I? Huh. There we go. And it's often nice to print like a separator. There we go. So you can see A and B start out at 0 and 10. We then reduce B by half because the intersect is 2, right? There we go. There we go. Actually, I could probably, let me print a few more things. just to show you how this works. And then print f at m is equal to f at m. There we go. So, we've got questions. Let me take some questions. So while I'm doing these types of Python programs in class, one of the I think the most useful thing you can do is after the lecture's finished, run the video back and go through it slowly and do it yourself at the same sort of concurrently. So yeah, can we pass functions as arguments in Python as well? Yes, you can. That's what I'm doing right here. This f is a function which is being passed as an argument. That's a question from a coder. Why not just return m here? Because this m will be out of date by the time I get to the end of the loop, because I will have modified a and b. So I get a slightly more exact and precise m by returning the expression that calculates m once we have our final a and b. F at m means the function f is passed the parameter m, just like in regular math. So m is a local variable to this function, not just the while loop. Again, question from a programmer. Question: if f1 is a function, why don't we include the parameters immediately after f1 on line 16? Because it doesn't need it. So it's a function, but it doesn't, all it does is calculate the value of that expression, right? So if I print f1 at, some big number, it'll calculate it, right? That one's very much like a mathematical function in the regular sense. Would this program still work if we didn't take the midpoint, but any point on the interval AB? As long as the point was consistent, I think you would get away with it. But the thing that you would lose is the ability to reduce the search space by half each time and have a 50% chance of it being before and after. So the middle is the correct choice, but I think, yeah, it could technically run if you picked 3/4 or something. So is that only letter f can mean a function? No. So this is a function. This is a function. In this, anything highlighted with this sky blue color, those are all functions. All right. So notice I'm using the function name here without invoking it. I'm using this here. So Python has this interesting characteristic, which is known as duck typing. This is getting a little bit technical, so if you're getting a little bit lost, don't worry too much about it. This is mostly for the programmer crowd. So duck typing means if it walks like a duck and it quacks like a duck and it eats like a duck, it's a duck, right? So this f, I'm using it like a function. In Python, that means it's a function. You'll get an error if you don't use it like a function consistently, but so long as you use it like a function, it's a function. And that's what we're doing here. So yeah. So that's, congratulations, that's your first Python program. And I just wanted to show you guys, how the program is actually narrowing down on 2, right? So if the midpoint is 5, then the f at m is 21. In the next iteration, the midpoint is 2.5. F at m becomes 2.25. We then narrow the interval again. M becomes 1.25. We get negative 2.43. So that's less So you'll notice A gets moved up, right? All this time we've been moving B down because f at m has been positive. But as soon as it goes negative, we start moving the A interval up. And we just narrow it and narrow it and narrow it and narrow it. And eventually we get a very, very precise view of what the x-intersect actually is, without having to solve things algebraically. This is a numerical method, not an algebraic method. Oh my god, don't talk about pointers. Please. No! Not pointers. Save that for 1xc3 when we do C programming, okay? And besides, in Python, you don't call them pointers, you call them aliases. Yep. Cool. All right. So, and thank you very much, all of you ComSci guys, for lending your knowledge to the people who might be finding this a bit tricky, because that's kind of like that's the type of behavior we want to encourage. That's misaligned, but whatever. So, yeah, no trouble, no trouble. It's just, you know, we can't talk about pointers yet. So Python will still consider that f is a function without you defining it first. Yes! So, within this program, very quickly, where is it? There it is. There's a big difference between f as declared here and f1, which is declared down here. So f1 is a separate function, but f here is a parameter of the intersect function. So this guy belongs to intersect. Once intersect is finished executing, it's destroyed. So this is like the concept of a local variable. So f is local to intersect with the name of f, but you can give it the name of a different function. So, but this is a little bit confusing. If you don't understand this stuff, you can, you know, take the course, like, just keep paying attention, because we'll get there. This is like a motivating example. You're not expected to be able to do this right off the bat, okay? Where should you be taking notes? Wherever you want. Take notes on your hand, on your wrist. Take notes on the back of a speeding squid. I don't care. It's up to you. So let's talk about programming languages. We have, in programming in general, two main families of programming languages. We have declarative languages, and we have imperative languages. So in declarative languages, you state what the properties of things are. All of you ComSci guys will also be taking 1JC3 concurrently with this course. I think so. And in that course, you will learn the beautiful programming language Haskell. I know you guys will probably not appreciate it, but, you know, a true artist has never appreciated it in their time. So, in a declarative environment, you say what something is. In an imperative environment, such as Python, you say how something is calculated. So, declarative languages will do a lot more work in the background to translate your description of the problem into a, into a real version that can be executed. Because fundamentally, all computers, like all CPUs, have to execute imperatively. That's how they work, right? A CPU, central processing unit, receives instructions and executes those instructions over memory, right? So, sooner or later, every programming language has to be translated to these highly, highly simple instructions called assembly code or object code. That's the purpose of a compiler or an interpreter, which is Python uses an interpreter, Haskell uses a compiler. We'll get into the difference. I'm getting slightly ahead of myself, but yeah, Haskell is like learning to code from the bottom up. Yes. Is this something that will be on the test? The test will be composed of programming problems, in very similar fashion to the assignments. I won't talk about the test too much, but basically, yeah, it's just programming problems. So, imperative descriptions. So each step in an imperative language is simple relative to declarative language. This makes it, easier to work with for a beginner. So that's why Python is like the beginner language. That's one of the reasons. Another reason is that they simplified the syntax. Why do you learn Haskell in first year? I'm getting a question. Why Haskell? It looks so scary. You learn it because it's necessary for upper year courses. Like I'm currently also teaching a course 3MI3, which is a course in the mathematics of programming language construction. And that course, like if you didn't know a functional language, I would have to teach it to you for the purposes of that course. So, yeah. So anyway, algorithms. An algorithm specifies a sequence of instructions to be executed by a machine that, when provided input, will eventually stop and produce some output. Technically speaking, it doesn't have to eventually stop for it to be an algorithm. It has to eventually stop for it to be a good algorithm. I'm not going to answer, like, after every slide whether this is going to be on the test, okay? You're just going to have to use your brain to figure out whether or not what I'm saying is important enough for you to pay attention to it, okay? So, algorithms. The concept of input and output is absolutely central, crucial to the idea of computation. You do not have an algorithm exists independently of the input and the output. When I write a function, you see that the input has been abstracted into variable names, and the output has been abstracted. But, the algorithm is configured to take input and produce output, right? Sometimes that input and output is just like things appearing in your terminal, right? But often it will be numbers. So, yes. A cookbook recipe is an algorithm which is intended to be executed by human beings. Notice that on recipe cards, the thing they list up front is the ingredients that you'll need. Those are the inputs to your recipe. The instructions are the recipe instructions themselves, and of course the output is hypothetically edible foodstuffs. A traffic light also follows an algorithm for switching the state of the car light, the traffic light. So inputs can be time and the presence of cars if it's one of those sensor types. Instructions are the conditions upon which the lights should be turned on, and the output are the electrical signals to the light bulbs themselves. Don't we use both declarative and imperative descriptions in programming? Would Python be a mix of both? So yes, you do. Particularly in Python, because like Python itself is known as a multi-paradigm language. So you can use aspects of functional programming inside of Python. However, we're going to only touch lightly on the ways that you can use Python declaratively. We're going to focus primarily on the imperative stuff because it's also important to be a good imperative programmer. But yeah, yes, you are correct. Python does use both declarative and imperative paradigms. Haskell doesn't use imperative, by the way. Haskell is a purely functional language. So, algorithms. The computation prescribed by an algorithm goes through a sequence of states, starting from an initial state, and each instruction leading to a new state. So, in our example of our, oh my goodness. In our example of Python 3, topic 1, this guy, all of these statements, these are all the intermediate states that your program will go through while calculating the result. The initial state is here, the final state is here, the result given there. The idea of state is very, very important. The state is the values that exist inside of the variables inside of a function. So, yeah, Arduino PTSD. Yeah. Would you be asked to formulate code through real-life situations such as baking? No, we are going to be solving math problems, not this isn't a class in Gordon Ramsay. But anyway, so a trace is something you perform over an algorithm to show all of the intermediate states. So when I inserted all kinds of print statements into the algorithm that I've now closed, there we go. That's not the editor I want. I want text editor? There we go. Yeah. By inserting these print statements to display the intermediate state, I am performing... This code is raw! No. I am performing a trace, right? All of these print statements constitute a trace of the program because it shows us the states. So, the term algorithm is actually derived from a dude's name who wrote a book on algorithms, which got bastardized into Latin to be something like algorithmy, and that eventually became algorithm. So, yes. In order to be a good algorithm, you need two properties. You need it. Both of these properties are necessary for a computer to be able to execute it. Like, the reason that a computer can't bake you a cake, right, is because the algorithm for cake baking is not precise or effective, right? So human beings can perform algorithms that are neither precise nor effective by inserting we fill the gaps with experience, knowledge, supposition, imagination, all of the things that computers don't have. In order for a computer to execute an algorithm, the algorithm must be precise, so each instruction and the next possible instruction must be unambiguous. There must be, no ambiguity as to what the next step is, right? So, with cooking, what the next step is might depend on, how effectively you performed the previous steps. Like, for example, if you put your chicken raw on the plate and Gordon Ramsay throws it in the bin and yells at you, your next step is to cook another chicken. But in a computer, basically computers have to be able to go through the entire algorithm blind, right? They're not really aware of whether the output that they've produced is good or not, right? In order for a computer to determine whether the output is good or not, you need to write an algorithm that can tell whether the output is good or not, and that algorithm must also be precise and effective. So, computers don't really know what output they give. They don't really know what input they get either. They're literally dumb machines, right? It's just a fancy calculator. And it's kind of funny, because we don't really think of computers as being stupid, but they are. Computers only do very, very simple things very, very quickly. Now, you can do... Like, right now, I'm doing enough stupid things quickly to be able to, like, live stream my, virtual presence to all of y'all. So, it's not like computers aren't effective tools and, essential for living in the modern age and all kinds of fun stuff like that. But, like, the CPU itself really only performs basic operations like moving memory around and addition and subtraction and stuff like that. It just does it so quickly that it looks intelligent when it's actually not. Any intelligence that you pick up from a computer was due to a human being putting something that looks like intelligence into a program. Anyway, so they have to be precise. You have to be able to follow one step to the other with no ambiguity about what the next step is, and an algorithm has to be effective. That is to say, the instruction must be executable by the underlying machine. So, there are, like, pizza vending machines now. I've seen these that you like, beep, boop, boop, type up, I want a pepperoni pizza. And I know we're out of time. I want a pepperoni pizza, and, like, one of the functions of the machine is to put a pizza down and put pepperoni on it. In that machine, making a pizza is an executable instruction. But in a regular CPU, such as the CPU in the, all of the computers that you guys are using right now, the only effective instructions are things like add, subtract, divide, multiply, move memory around, various bitwise operations, etc., etc., etc. But, yes. So, yeah, as your colleague points out, it is now time. It is time to finish this lecture and continue to the next one. So, yeah, let me just quickly see if there's anything worth answering in the chat. If they knew, they wouldn't need us anymore. Yes. For the weekly reading, when you try to open the link, it says refused to connect. Oh, okay. I'll take a look. I'll add that on my list of things to do today. Take a look at the weekly readings. Yep. Okay. I'm gonna write that down. Thank you for bringing that to my attention. I haven't fixed the links in the syllabus yet, but weekly reading links. There we go. Is there anything we should do specifically for the next lecture specifically? No, just, not particularly. Time for the Haskell, yes. Next, should we... Oh, yeah, no, I'm gonna I'm gonna, like, the topics are roughly one per week, but, I inevitably get behind. But, yeah. Okay. Um, what does comp sci 1xd3 teach? It teaches ha. No. My understanding of 1xd3, I don't teach it myself. I haven't taught it myself, but it's kind of like web stuff, learning like Django and like a little bit of databasing, how to set up a web server, that kind of stuff. Very cool course. But yeah. You should not finish this on your own. We will finish it ourselves in lecture. Could I make a post on Avenue telling us when the readings work? Yes, okay. How are you supposed to know how you wrote the things I did in Python? That's, the purpose of the course is to learn how to Python program. That was a slightly more complicated example. You probably, like, give it to the end of, like, topic 3, and you should be, like, on more of a level with being able to produce the type of program that I showed you. But, yeah, the way that you learn programming is by practice. Will we continue this lecture another time? Yes, we will continue this lecture another time. What is it? When's our next class? Is it Friday? We will continue this topic on Friday. Is A1 due this Sunday? No, it's due this Sunday 2 weeks from now, or 3 weeks from now. It's in the syllabus anyway. JHub, will our assignment be submitted after we run the code? Oh, no. So the way that the assignment works is like you type up your code, and then when you're so happy with it that you're certain you're going to get 100%, there's a separate button you can click to submit it. So validating and submitting are different things. Validating just means it checks it to make sure there are no bugs, or not bugs, like it executes. It checks the metadata to make sure that your notebook isn't broken, which can sometimes happen. But don't worry about it because it's rare. And yeah. Which platform should you be using for programming? Download Anaconda and use Anaconda. That would be a good way to go. VS Code is a good IDE. IDE stands for Integrated Development Environment. So, like, when I have to do a little programming project when I'm on Windows, I usually use VS Code. It's really good. Yeah, a lot of this will be explained to you in your tutorial next week. So, yep. Is the counter when you run a code block in the assignment used to calculate the grade? No, it isn't. That's just like informational for you. The thing that's used to calculate your grade on the assignment is whether or not the program works. We run test cases on it, and if those test cases come out true, then the code works and you get marks. Can you use IntelliJ or Eclipse? Yeah, sure, if you want to use Eclipse. I'm not sure I would recommend Eclipse, but yeah, I just hate Eclipse. Can you use VS Code instead of Anaconda? You can use VS Code to do like the examples that I'm doing in class, but you're going to have to use Jupyter to do the assignments, if that's what your question was. The assignments are only graded by test cases. We are not grading for best practice. I actually have a theory about that. When you're first learning to program, you kind of have to have the wiggle room to be able to write code that's bad but still works, because then you'll be able to, like, that's like, it's the freedom to write code at your own level, and that's how you get into it and improve your level. Not by me telling you this is the only way to code. There is not just one way to code. There is a million ways to code any particular program, and you need the freedom to figure out programming for you. There you go. Can you use PyCharm? Yeah, if you want. I'm not sure what collab is. Huh. Oh, Vim Gang. Yeah. Okay. Well, I think that's everything for today. I'll let you guys get along to your next class. Take her easy, folks. I'll see you on... Oh, should you be this intimidated by coding already? Well, it's like, you know, I don't know how intimidated you are, so maybe it's a correct level of intimidation. Yeah, like, coding isn't easy, but, you know, this is we'll start with easier examples than this and work up to this sort of thing. But yeah, don't worry, this is a course. You're not expected to already know how to program. I'm going to teach you how to program. Follow through with just follow the examples the best you can. If you need extra help, do some extra problems. And, yeah, you know, it's just work. You get, like, learning any language, it's like, you just gotta work on it, you know? Yeah. And if you're having trouble, like conceptual trouble, please seek help from, like, Piazza or the TAs or myself. Like, yeah, if you're having difficulty, I think we're going to, like, I'm in the process of setting up office hours with the TAs, so you guys will have as much help as you want, basically, despite the fact that this class has like 250 people in it. But, yeah. Alright, take her easy, folks. Don't do anything I wouldn't do.